Let's see how to use the boring head in real life. We'll select our boring bar and we'll lock it into place. Now during our actual demonstration, I'm going to be using a longer bar than I would for this thickness of material, but that's to allow some clearance so the camera can get a good view of the cutting action. When we put the boring bar in, we need to make sure that the cutting edge of the boring bar is aligned with the center line of the spindle. That's very important because if it's canted to one side or the other, the diameter of the cut is going to be affected, and the precision screw will not indicate the amount of movement being cut correctly. Next, we'll gently snug the jib screws. Now we want them tight enough not to allow play in the slide, but not so tight as to restrict its movement. So we're going to adjust them while we move the slide back and forth, which will allow us to get it just about perfect. And here's our workpiece, set up, centered, and squared away. This is a 1/2 inch hole that we want to bore out to 3/4 of an inch, or 0.750. We'll set some inside calipers 50 or 60 thousandths smaller than the desired finished measurement to use as a sort of quickie gauge. It'll let us know when we're getting close to our desired size. Let's begin by lowering the boring head and moving the tool to the center of the bore. We'll open the head up by using an Allen wrench and the precision screw, and we'll do this until we just feel the cutting bar touching the side of the workpiece. At this time, we'll slowly turn it by hand to make sure that it's touching but not binding at all. This is going to be our starting position. Now we'll tighten the locking screw. Once that's secured, we're free to raise the spindle and start the mill. This is a copy of Machinery's Handbook. Between its covers is a complete engineering course. Now, this is an old copy, it's from the 50s, but it's still full of more pertinent information than I'll ever be able to utilize. New copies can be rather expensive, but going online to a used bookstore can net you an older issue for a fraction of its cover price. Now, I got this 1950s 15th edition in very good shape for the princely sum of $10. Similar deals come up all the time. I suggest that you get a copy. The small thumb tab here is entitled Speeds, Feeds. Now, in the next 37 pages of this particular issue is a plethora of tables, charts, and formula devoted to finding the best speed and rate of feed for your particular operation, cutting tool material and shape, metal type and hardness, size of stock, etc., etc., ad infinitum. For our mini machines, a lot of this information isn't really going to be practical. Our smaller mills and lathes won't tolerate the same operational stresses as machines that are made from tons of sturdy cast iron. So we tend to base our speeds and feeds on empirical evidence, which we gather by making cautious first cuts and proceeding from there. Now, I mentioned before in the animation that vibration can cause serious problems, especially when using an unbalanced tool such as the boring head. Not only can it cause safety concerns, but it can also cause inaccuracies. Watch as we slowly increase the spindle speed. Now, at first, the mill begins to shudder along the x-axis. As we increase the speed even more, we'll see the shuddering seem to stop briefly, then resume, but this time along the y-axis. As the speed is increased even more, the shuddering seems to stop. In reality, the oscillations are still happening, they're just happening faster than we can see the mass of the mill react to them. They will still cause flexion between the column and the base, which can result in out-of-round bores at the minimum, and serious safety hazards at worst. So please be cautious and use speeds that will avoid this problem. Lower the spindle slowly through the workpiece, and then slowly raise it back up again. This is our first trial cut. It gives us our starting point. Once you've raised the spindle, then you can stop the mill. Now we're going to loosen the locking screw. Then we're going to dial in our first actual cut. Now remember, a thousandth that's dialed in here is actually 2/1000ths in bore size. So take your time. Start out with small increments, 10 or 15 thousandths or so, just to see how your mill, the material, the speed, and the cutting bits are all interacting. When you've dialed in your desired cut, make sure that you note the setting. Once you've noted your setting, Go ahead and tighten the locking screw in preparation for taking the next cut. Go ahead and make your cut, slowly and as smoothly as possible. Now if your boring head starts to chatter, don't panic. The normal response would be to increase the spindle speed and ease up on the cutting pressure, but actually that's just about the opposite of what you need to do. Instead, decrease the spindle speed and gently increase the feed or cutting pressure. Surprisingly, this will usually cut the chatter, so to speak. Of course, each situation is different and you'll have to be the judge of what is working and what isn't, so just keep a cool, level head and keep thinking safety first, of course. To avoid springback or flex problems, you want to make a second slow pass without changing the setting. On this second cut, the tool will be able to cut the sides of the bore without the pressure of having to remove all that material that was taken out on the first pass. This will allow the natural rigidity of the tool to accurately cut the sides of the bore without flexing, helping to avoid any taper and giving you a much more true and accurate reflection of the measurement that you dialed in. For our next cut, let's dial in 20 thousandths and see how that works. Now remember, 20 thousandths on the dial is actually going to cut 40 thousandths out of the bore. After you've dialed in your desired cut, remember to set the locking screw. Now you can see from the thicker chip being produced that this is a heavier cut. Heavier cuts are going to put more pressure on the boring bar, especially a longish one like the one we're using, so our springback cuts will be even more necessary. Moving right along, this was a 25 thousandths cut. As you can see, it's taking a lot of material, nearly 50 thousandths of an inch. The cuts this deep are possible on some materials and not on other harder materials, but on aluminum, even 6061 T6 aluminum like this, we can still get a nice cut at this depth. Without changing the setting, we'll take a springback cut with the camera at this angle so you can see how much material is actually being removed on this second pass. That's quite a bit, isn't it? That thin sheet of aluminum that's being peeled back is several thousandths of an inch thick. The amount of flex in the boring bar is rather surprising, but watch as we take a third cut. Now again, more material is being removed, but this time mostly from the bottom of the bore, as the boring bar removes the last traces of any taper. As you remember, we set up some inside calipers to act as a gauge to keep us appraised of our progress. Now that they're telling us we're close to the final size, we'll need to get out our telescoping gauges and make very careful measurements on each pass. Transferring our telescoping gauge measurements over to the 1-inch micrometer, we find out that we're reading .726, or only 24 thousandths under our 750 target. Now, normally the way I'd cut the remaining 24 thousandths would be in several passes of smaller and smaller increments, sneaking up, so to speak, in our final measurement to be sure I don't overshoot it. But I'd like to demonstrate just how accurate the boring head really is. If you take the time to do spring-back cuts, as we've done, and you've measured carefully, the boring head will do exactly what you want. So for purposes of demonstrating that, I've set the cut for .012, which would be the entire 24 thousandths. I'll make that cut, continue with 2 spring-back passes, and complete with a finish pass. And we begin. We've completed our cut and spring-back passes, and we're on our final finish pass. For finish cuts, it's a good idea to engage the fine feed dial and feed the boring bar through as slowly and uniformly as possible. The slower and smoother, the better the final product. And here we are taking our final measurements. And the micrometer shows we're right on the money. Pretty neat, huh? The boring head is a great little tool. Once you use it, you won't want to live without it.